Hello class, how are you doing? That's a second video regarding optimization from chapter 15.7 on the bricks and 13.8 from Larson calculus. First, what is a critical point? Critical points, this is a graph of a parabola which I reciprocated, like y equal to x squared, which is right here. And if I put y equal to 1 over x squared, when y is 0, what is 1 over 0? Undefined. And this is infinity. What is 1 over infinity? You go to 0. And to this side, 1 over infinity go here. I don't know what's going on to the y value here. Let's call it a critical point. Therefore, if I take the derivative of that function, which is really x to the power of -2, the derivative of it is -2x to the power of -3, which is -2 over x cubed. You know, at x equal to 0, my derivative is not defined because it's not part of the domain. Therefore, wherever the derivative does not exist or is undefined, you have a critical point. And that critical point does not lead to a max or a mean. And I hope somebody knows when I talk about critical point means the day you are born is a critical point. The day we die is a critical point. Not you, I'm talking about myself. The day you get married is a critical point. The day you have your first child is a critical point. You know, these are called critical points in your life. The day you graduate is a critical point. Therefore, when you have a function, my revenue will go up, reaches a maximum. Suddenly, coronavirus come around, and my revenue start going down. That day was my critical point. I was a rich person. Suddenly, I'm losing money. Therefore, at a critical point, your derivative is 0 or derivative is undefined. When you come to multivariable function, whatever f of x and f of y, if both of them are defined and you can set them equal to 0 and solve, that's a critical point. Or at the least one of them, these or these, does not exist. These are critical points. I'm going to have a function of x squared minus a 4x plus a y squared plus 8x. And I'm going to say, I have no clue what that is. Would you tell me where do I have a max? Where do I have a mean? Do I have a max or a mean? And please remember, when you talk about max and mean, there are two types of them. Sometimes you are the richest person in the whole world. All over the world, you are the richest person. Somebody like Bill Gates. That's called absolute max. And I bet you if Bill Gates is the richest person, I bet you there is somebody in the world that have the least amount of money and is the poorest person. That's called absolute mean. But sometimes you go to a country that you see too many rich people. Too many rich people and also too many poor people. Is he the richest person in the United States? No, because they have same amount of money. I'm sorry, the allergy is bad. But if I divided this interval to a different county in the United States, I said in this county, that guy is the richest person. This is called relative max. I bet you in this county, he is that, whatever his name is, maybe that name is Muhammad. That Muhammad owed $10,000. Oh, $10,000. He's the poorest person in that county. This is called a relative mean, relative to that county. I bet you there is somebody more than I do in the whole world. Therefore, you have to know what is the absolute max and absolute mean. Therefore, I'm going to come back here and say, okay, do I have, I'm talking about relative, max or a mean? F of x equal to 2x minus a 4 equal to 0. F of y equal to y squared plus 8 equal, no y squared, that's 2y, equal to 0. Simultaneously equal to 0, x is 2. Simultaneously x equal to y is negative 2. I don't know if this is a relative max. It is a relative mean. Maybe it's a saddle point. I don't know what it is. I have to go back and do the second derivative test. What is f of xx? 2. I bet you that's a positive. And if this is a positive, if the d become a positive, that produces a minimum value. I don't know yet. Let me check. What is f of xy? 0. What is f of y is 2. And what is f of yx is 0. Therefore, I have a 2 and a 0, 0 and a 2. I know my determinant is 4. I got that a positive. What is f of xx? My f of xx is 2. Oh, that's positive, that's positive. What is positive times positive? Oh, I know positive times positive in algebra is positive. But when you talk about optimization in multivariable, positive and a positive give you the minimum value. That's the minimum value. Therefore, if I put right here 2 and a negative 2 for x and a y, which is 4, minus 8, plus a 4, minus a 16, that's 8, 0. The lowest value take from any order pair, from heaven to hell, the minimum value is negative 16. But I'm going to teach you a new way sometime. I don't want to do second derivative test. Here, you know what? I don't have mixed variable. I put x squared minus 4x. I'm going to complete the square. Give me half of that. Negative 2. Square it, add and subtract. This is x minus 2 squared minus a 4. Do you see how I find that x equal to 2 right here? And complete that one. Y squared plus 8x. Remember, this coefficient has to be 1. If it's not 1, you have to factor it. Give me half of it, 4, 16 minus 16. Therefore, this is y plus 4 squared. I did something wrong because I got negative 2 here. See, I can check already I made a mistake right here because 8 divided by 2 is a 4. Even if it does not change any of these answers, because these are all constant, here it make a changes right here. See, because I did the other way, I find that I made a simple mistake. 8 divided by 2 is 4. 8 go to other side, become negative, negative 4. Therefore, this is 2 and a negative 4. And that become a 4 minus 8. But that become a 16. And 8 times 4 is negative 32. And see, that's make it negative 16, negative 24. Oh, that make it a negative 20. That's the mistake, simple mistake I made. I'm glad I checked it the other way. Okay, therefore, instead of f of x and y, writing it like x squared minus 4x plus y squared plus 8y, I'm going to write x minus 2 squared minus plus y plus a 4 squared minus 4 minus 16 is negative 20. Do you see that negative 20? That negative 20 is right there. What happens if x become 2 and x become a negative, y become a negative 4? For x equal to 2 and y equal to negative 4, this becomes 0, this becomes 0, the z value is negative 20. But in no matter what x is, Anything other than 2, when you square it, it becomes a positive. When you square it, become a positive. Therefore, you have 2 positive number. When you add 2 positive number, become positive. And then when you subtract 20 from it, it's going to become less than 20. Therefore, 2 and -4 is going to give you the minimum value. And that's it. You can do complete the square. But somebody said, man, that was easy. What happened if I come right here and I come up with some examples that I cannot complete the square? Maybe I come with f of x, y equal to, maybe I put x squared and I have y cubed. I'm going to have a mixed variable to make my life tougher, minus a negative 18y and minus a 6x. Remember, this is no longer you can complete the square because you have a mixed variable. And it's not easy to solve for f of x and f of y, but put them simultaneously equal to 0 is not going to be easy. F partial with respect to x is 2x plus, boom, 6y minus a 6. What is partial with respect to y? 3y squared plus 6x minus 18. Set them equal to 0. See, this is x and y are mixed and is not easy to solve. And some students said, hi, I'm gonna do this problem like that. I said, you go back to your 7th grade math teacher and say, how do we solve system of equation with 2 variables? Are they going to say substitution method or additional elimination? Therefore, do you want me to kill the x? I multiply this by -3. And all is left is the y value. I don't have y in both of them to kill the y. Or I can solve for x in here in terms of y and substitute it here. But in here, I'm going to put a brace in here, and I'm going to multiply this one by -3. Then what do I get? I get -6x minus 18y plus 18 equal to 0. Here, I'm going to copy itself because I'm not multiplying by anything because my x is going to have same coefficient, opposite quantity. Oh, this is gone. Oh, that's gone too. Beautiful. I have 3y squared minus 18y equal to 0. I factor 3y. I have y minus 6. One answer is y equal to 0, y equal to 6. Please give me a call if I'm making simple mistake here. Then go back in here and say, when y is 0, what is your x? X is 3. When y is 0, x is 3. What happened when y is 6? What is 6 times 6? 36. What is 36 minus 6? It's 30. 30 go to the other side, become -30. -30 divided by 2 is 15. Therefore, it becomes 15 over 6. Let me check, make sure I did it right. 36 minus 6 is 30. 30 go to other side, become -30. -30 divided by 2 is -15. -15. Let me do it again. 36 minus 6 is 30. 30 go to other side, become -30. -30 divided by 2 is -15. But I don't know if these two are saddle point, if it is a max or a mean. But I need the second derivative. What is f of xx? 2. F of xy? 6. What is f of y? 6y. But what is f of y x? 6. They should be the same. If these two are not the same, you messed it up. Therefore, when I'm going to do one ordered pair at a time, 3 and 0. 3 and 0. Remember, x is 3, y is 0. Okay. F of xx, f of xy, f of yx, and f of yy. I'm going to do this one for what? I'm going to do this one for 3 and 0. And what happens 6 times 0? 6 times 0, make it a 0. And what is the determinant right here? 0 minus a 36. Oh, that's less than 0. Don't waste your time. The d is not positive and it's not 0. If it was 0, then become inconclusive. This is a saddle point. It is a turning point, but I don't know if it's under the horse belly or is under the place you're sitting on it. You know what I mean? Let's do the other part. Negative 15 and 6. Negative 15 and 6. This is 2. F of xy is 6. This is 6. But what is 6 times 6? 36. And that becomes 72 minus 36. 72 minus 36 is 36. Oh, that is a positive. And what is f of xx? F of xx is 2. That's the positive. And what is positive times positive in optimization? Minimum value. That's the mean. Somebody said, okay, what was your saddle? 3, 0. What is your z value at that point? You got to go in here and say my x is 3, my y is 0. 9, 0, 0, 0, minus 18. 9 minus 18, negative 9. That's where you see at that point, you see a what? A turning point, which neither is max or a mean. The other one was negative 15 and 6. Oh, I don't think I can do this in my head. I go to my function and I'm going to go right here, which I have x squared, which is 225, y cubed, 6 times 6 times 6 is 216, 6 times 15 is 90, 90 times 6 is 540, but is a negative. Negative 18 times 6 is 60 and 48 is negative 108. And negative 6 times negative 15 is a 90. Therefore, 6 and 5, 11, and 0 is 11. 1 and 9 is 10, 11, and 13. 1 and 2 is 3, and 2 is 531. Minus a 540, minus a 108. The difference between this one is a negative 9, minus 108, together is negative 118, negative 118, and I promise you at that point, that function is going to have the minimum value. Everything else is more than negative 118. And this one is optimization of a multivariable by finding the critical point, f of x equal to 0. And in order to do it, both you have to have partial with respect to x, partial with respect to y. Or if at least one of them is 0, these two are going to be critical point. But the critical point that f of x is equal to 0 and f of y is equal to 0, and you can solve for x and y, it will produce either max or mean or saddle point, one of these three, by using the second derivative test, which second derivative test is going to have 4 second partial derivative. Thank you and have a great day.